Friends, today's topic is naming of functions. Naming of functions is divided into two categories. First one is algebraic functions, another one is transcendental functions. Algebraic functions are the functions consisting of finite number of terms involving powers and radicals of the independent variable, constants and fundamental mathematical operations like addition, subtraction, multiplication and division. Otherwise, the functions are transcendental. Now, we shall discuss in algebraic functions three types of functions, respectively polynomial functions. Next one is fractional rational functions. Third one is irrational functions. And in transcendental function, you will find exponential functions, logarithmic functions, trigonometric functions. Also, there are some special functions, respectively absolute value function, sine function, greatest integer functions, fractional part functions and least integer functions. We shall only discuss the algebraic and transcendental functions in this video. On the next video, you will find some special types of functions. So first of all, we start with polynomial functions. Friends, in polynomial function, let us consider that fx is equal to a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus so on plus an minus 1 x plus an, where a0, a1, a2 ... an minus 1 an are any given real numbers and n is a non-negative integer, that is n is an integer which is greater than or equal to 0 is called a polynomial function. This type of function is a polynomial function. As for example, say fx is equal to 5x to the power 4 minus 7x cube plus root 5x square minus 3x plus 9. This is a polynomial of degree 4. Take another example, say gx is equal to 2/3 x square plus root 2x minus 5. This is also a polynomial function with degree 2. If I say px is equal to 2/3 x square plus x to the power half plus 3, this is not a polynomial function since there is a rational fraction half. So this is not a polynomial function. This is an only algebraic expression. The domain of any polynomial function is always R, and its range will depend upon the function, nature of the function. Okay. Next we discuss on a rational function. Next is a rational function. What is rational function? A function, say fx, which is of the form px by qx. Okay? A function fx is of the form px by qx, where px and qx are polynomials and qx is not is equal to 0. That is, qx is not the 0 polynomial, is called a rational function. As for example, say fx is equal to 3x square minus x plus 7 whole divided by, say, x to the power 4 minus 8x cube plus 5x square minus 6 is a rational function. The domain of the rational function px by qx is the set of all real numbers except those at which qx vanishes, that is, becomes 0. And next we shall see what is an irrational function. Next is irrational function. Irrational functions. Friends, let us consider that y is equal to fx be a function. Operations of addition, subtraction, multiplication, division, and rising to a power with non-integral rational exponent. This is very important. Rising to a power with non-integral rational exponents are performed on the right hand side of the function y is equal to fx is irrational. As for example, say fx is equal to root x, or say fx is equal to say x square plus root x whole divided by root over 1 plus 7x square, etc. Next we shall study on transcendental functions. In transcendental functions, you will find exponential functions and logarithmic functions. So first of all, we start with exponential functions. Exponential functions. Friends, the functions fx is equal to a to the power x, where a is greater than 0 and a is not is equal to 1, is called an exponential function with base a. This a is a constant. Its graph is like this: x-axis, y-axis, origin, and this point is say 0, 1. The curve is like this. This is a to the power x when a is greater than 1, that is the base is greater than 1. And also you can consider another curve of a to the power x which will again pass through like this, which will again pass through 0, 1, and this is a to the power x when the base a lies between 0 and 1. A lies between 0 and 1. This is not a straight line. This is just a curve and will pass through the point 0, 1, and it will not touch the x-axis. Mind it, this will not touch the x-axis. The range is from 0 to positive infinity, excluding 0, and domain is R. Next is logarithmic function. Logarithmic functions. The function fx is equal to log x base a, where a is greater than 0 and a is not is equal to 1, is a logarithmic function. And this function is defined if x is greater than 0. This is very important. Function will be defined when x is greater than 0. So what will be the curve? The curve will be like this. This is x-axis, origin. This one is y-axis. This point is 1, 0, 1, 0, and the curve of fx is equal to log x will be like this. This is log x base a, but this is only when a is, that is the base is greater than 1. And this curve of log x is equal to a may be like this also. Again we'll pass through 1, 0, and this will happen only when 0 less than a less than 1. 0 less than a less than 1. Next we shall discuss on the trigonometric functions. The first trigonometric function is sin x. So we shall start with sin x. Friends, the function f which associates each real number x to the sign of the number is called the sine function. As for example, say fx is equal to sin x. Okay, so this sin x is the sine function. Okay, here x is the radian measure. This x is the radian measure of the angle. Since for each real number x, sin x is a unique real number, so sin x is defined for all x belongs to R. For all x belongs to R, and thus domain of sin x is R. So the domain of sin x is R, and also the range of the sine function is closed interval -1, 1. This is the range. This is the range of the function sin x, and x belongs to R. This is the domain of the function sin x. Next we shall discuss on cosine function. Say fx is equal to cos of x. This is the cosine function, and its domain is R. Its domain is R, and the range is -1 to +1. Closed interval -1 to +1. Next we shall discuss on the tangent function. Say fx is equal to tan of x. Is called the tangent function. We know that tan x is equal to sin x by cos x. Okay, sin x by cos x, and this tan x, that is sin x by cos x, is not defined when cos x is equal to 0. That is when x is an odd multiple of pi by 2, isn't it? So tan x is not defined at the points where x is an odd multiple of pi by 2. That means domain of tan x is R minus 2k plus 1, that is the odd multiple of pi by 2, where k belongs to z. Okay, so z denotes the set of integers. Since tan x may assume any real value, so range of tan x is R. The range of tan x is R. This is very important. The domain of tan x is R minus the odd multiple of pi by 2, and the range of tan x is R. All the graphs are shown in another video. The video link is given in the description, so you may visit there also. Next we shall discuss on the cosecant function. What is cosecant function? Let fx is equal to cosec x. This is the cosecant function, and you know that cosec x is equal to 1 by sin x. Now cosec x, that is 1 by sin x, is not defined when sin x is equal to 0. Denominator cannot be 0. When sin x is equal to 0, that is x is equal to k pi, where k is an integer. Okay, so domain of cosec x is R minus k pi, such that k belongs to the set of integers. So domain of cosec x is R minus k pi, such that k belongs to z. And what will be the range of cosecant function? Friends, since you know this, modulus of sin x is less than 1 for all x belongs to R. So modulus of cosec x is greater than or equal to 1 for all x belongs to R, where cosec x is defined, that is cosec x is greater than or equal to 1, or cosec x is less than or equal to -1, isn't it? Thus cosec x never lies in the open interval of -1, 1. Okay, so what will be the range of cosec x? The range of cosec x is r minus the open interval -1, +1. That is, you may write this also in this way. Open interval -infinity to -1 closed union closed 1 to +infinity, open. Okay. Next we shall discuss on the second function. What is second function? Friends, let us consider that fx is equal to sec x. This is actually the second function. We know that sec x is equal to 1 by cos x. Now sec x is equal to 1 by cos x is not defined when cos x is equal to 0. That is when x is an odd multiple of pi by 2. So the domain of sec x, is equal to r minus the odd multiple, that is twice k plus 1 whole pi by 2, such that k belongs to z. Z means integer, set of integers. So this is the domain of sec x. And since modulus of sec x is greater than or equal to 1, you know this one, modulus of sec x is greater than or equal to 1 for all x belongs to R, where sec x is defined. Therefore, what will be the range of sec x? The range of sec x is thus r minus the open interval -1, 1. The range of sec x is r minus the open interval -1, 1. Please see the video of the graphs of sec x, tan x, cosec x, sin x, cos x. These are in the previous video. So links are given in the description. Please visit there also. And finally, I shall discuss on the cotangent function. Let us consider that fx is equal to cot x. Okay. So this is the cotangent function. Now what is cot x? Cot x is equal to cos x divided by sin x. Cos x divided by sin x. Now cot x, that means cos x by sin x, is not defined when denominator is equal to 0. That means sin x is equal to 0. Isn't it? So sin x is equal to, that means x is equal to k pi. When sin x is equal to 0, that is when x is equal to k pi, where k is an integer. So domain of cot x is r minus k pi, where k belongs to z. This is the domain. Since cot x may take any real value, so range of cot x is obviously r. Range of cot x is obviously r. Please friends, rewind this video, see again and again. I have just discussed here about the trigonometric functions, all the trigonometric functions. The graphs are not shown here. You please visit the trigonometric graphs where the graphs are shown. The videos are very important. You go through these videos. The links are given in the description. Thank you. Have a nice day. See you again.